Okay, in this presentation we're going to look at random variables. Consider two random variables, x and y, where the expectation of x is equal to 2. Okay, here we go. The variance of x is equal to 4. The expectation of y is minus 3. The variance of y is 1, and the covariance of x and y is 1.6. Calculate the expected value of 5x plus 20y, correlation coefficient, the expected value of the product, and the variance of the difference of x and y. So essentially, this is quick enough really. Essentially, the expected value of x, or the expected value of 5x plus 20y is equal to the expected value of 5 times the expected value of x plus 20 times the expected value of y. You just expand it out like that, almost like factorizing it. So 5 times 2 gives us 10, minus 20 times minus 3, that gives us minus 60, and then we end up with minus 50 there. That's straightforward enough, really. Okay, the next part is the correlation coefficient. Okay, now usually this is quite a lot of work, but in this case we're sort of given a lot to work with. Really, this is a very introductory style question, but this is the key formula that you got to remember. Okay, and really this part here is just testing you on this. Do you know this equation here? And you really have to have it learned off by heart. Okay, have it like a reflex. Okay, so essentially what we're using there is all the terms that were given above, the covariances and the variances of x and y. So essentially this term here, that term there, that's our in the denominator, and the numerator is the covariance there. Okay, so it is 1.6 divided by the square root of 4 times 1, which is 1.6 divided by 2, and that gives us an answer of 0.8. All right, now the expected value of x times y. Okay, so this expression here, don't know where that comes from, but just ignore that, is sort of, in the first instance, you think, how will you go about that? But essentially what you got to do here is remember these formulae, like this formula here. Now this is the expected value of x times y minus the expected value of x times the expected value of y. That's another formula you have to remember. Okay, that one there. So essentially what we're going to do is use that, but what we're going to do is simply rearrange it mathematically, because we know what the covariance is, so we know what the expected values are. Okay, so from that we can determine the expected value of x times y. So it's 1.6 plus 2 times minus 3. That is 1.6 minus 6, which is minus 4.4. Okay, finally, this is the variance of the difference of x and y. Okay, now essentially what we're going to do here is just multiply it out, really. Well, actually, do you know what? You can actually sort of invoke this formula immediately. Okay, but so the variance of x plus the variance of y minus 2 times the covariance of x times y. Okay, sorry, I'm using a variant term there for variance of x, but that's the variance of y there. Okay, so that expression there is one that you probably can invoke normally. Okay, the variance of x plus y, variance of x minus y. So just actually the key thing there to remember is that there's a plus sign there. Okay, how you work that out actually is the variance of x minus y. Nah, I'll leave it alone. It's a long explanation to it. So just for this particular video, we can just invoke this. Okay, doing a long derivation here is probably against the idea of what this video is about. So 4 plus 1 minus 3.2, that gives us 1.8. So yeah, we'll leave it there.